Hi everybody, welcome back. Here we are today, ready to learn lesson 92. And today we are going to spend some time looking at circles and angles that are formed by tangents and secants within those circles. So I am going to put the date on here for Tuesday, so that would be April the 7th. And here we go. So first of all, you have a do now problem. This do now problem is supposed to be really just a review of a whole bunch of the rules that we have already learned. If you would like to shut this off, try them first and then come back to check them, go right ahead. I'll be here. Here goes. So they tell me here that the measure of angle QOR is 35 degrees. And they also tell me the measure of arc PS is 40 degrees. So the way that we start from that is that 35 degrees is a central angle. So the arc that it is intercepting is the same size. So if this central angle is 35 degrees, the arc that it's cutting off is also 35 degrees. This 40-degree arc, however, is coming from an inscribed angle. So the inscribed angle is supposed to be half the size of the intercepted arc, meaning that angle in there would just be 20 degrees. Now, how do we figure out the rest of those arcs? Well, we're going to use that diameter again. If you watched my video on the last couple of homeworks, you will have noticed that I pointed out when they give you the fact that you have a diameter, that is very, very valuable, because what that does, it allows you to see that wherever that diameter is, the circle is cut into two 180-degree arcs. So in order to figure out arc QP over here, I can just do 180 minus 35 and come out with 145 degrees. So I know that this arc over here is 145 degrees. And then for this arc over here, I have the same sort of situation. The other half of the circle has to add up to 180 degrees. So 180 minus the 40 that they gave us down here means that this other missing arc is 140 degrees. Now you might notice as I went to do this problem, I didn't even look at the questions they were asking me. I just went and tried to label things. That's usually the way that I work, but you are welcome to follow the rules if you want to and go through the problem one step at a time. So the measure of arc QR, as we said, matched the measure of angle QOR, so that was a 35-degree arc. The measure of angle QOP from Q to O to P, well, that's the central angle over here on this side, QOP, which means it's going to be the same size as this arc that it's intercepting. So that is a 145-degree angle stuck in there. Then they asked for the measure of arc QP. Arc QP, we just figured out again, was 145 degrees. They ask for the measure of angle PRS. PRS is an inscribed angle, so it's half of the intercepted arc. Half of 40 is, of course, 20 degrees. And then last but not least, they wanted RS, and that was the work that we did over here. If we know this piece is 40, then 180 minus 40 is 140 degrees. And those are your answers for the do now. Now, before I go on to the rest of this lesson, I am going to just briefly go over again the difference between a tangent and a secant. Tangent and secant are both lines that are drawn to a circle coming from a point that is outside of that circle. However, the other really key important part of that is how many times that line or any extension of that line will hit the circle. So when we're talking about a tangent is a line that touches the circle at exactly one point. So in this example, PA is the tangent line. If I go from P to A, even if I keep going and go past the circle, that line that PA is a part of will only hit the circle in exactly one place. It'll never hit that circle again. That makes it a tangent. The tangent line is a line that's only going to hit into that circle once, no matter how long you make it. And then the other thing like that we talk about here is a secant line. And a secant line is a line that will hit into a circle twice, no matter how long you make it. So when I take a look at this over here, the line that intersects a circle at two distinct points, I must be talking about segment or line rather, I guess I could say, or ray, to be really official, it would be ray PC. And then if I would like to label it even more specifically, I could call it ray PBC, because it is clearly starting at P, going through B, and continuing to C, and then going beyond that. So that's your difference between the two. The reddish orangish one up here is tangent, and the one below it is a secant. Now, it turns out that there's something kind of nice about these rules that I'm about to explain to you now. They technically are listed as 3 separate rules, but it's really just one big rule. If you learn the one rule, you don't have to do anything else with that. So here we go. The situation that you have going on here is the following. If you have 2 tangents or 2 secants, or 1 tangent and 1 secant intersecting outside of a circle, then the angle formed will always be equal to half of the difference of the intercepted arcs. So of course that's just words right now. You need to see it, so I'm going to show it to you. So first situation they're talking about is if we have 2 tangents. Well, if I have 2 tangents that are meeting outside of a circle, that means from some point outside the circle, I'll call it point P, we have a tangent line coming to the circle on one side, and we have a tangent line coming to the circle on the other side. So if I call these points A and B, this is a situation where I have 2 tangents drawn to the same circle. The measure of this angle P out here will be what I get if I take the bigger arc that I'm hitting into and subtract the smaller arc that I'm hitting into. So the bigger arc would be from A all the way around here to B, and the smaller arc would be the arc that's over here that's just going from A to B. As you can see just by looking at it, the one that's closer to it is always going to be the smaller one. So if I wanted to find the measure of angle P here, that would equal the measure of, now this is a big arc here from A to B, so I'm going to put a C here just so I can make it easier to write. That would be the measure of arc ACB minus the measure of arc AB and divided by 2. In other words, that general rule that they talked about up there, it would be the big arc minus the smaller arc divided by 2. Now I'm going to look at the same kind of situation when I move to there being 2 secants instead. If I have 2 secants drawn to the same circle from the same point outside the circle, I'm going to make this point P out here. If I draw 1 secant going to the circle, I'll call that P, A, B. And then another secant coming to the same circle, I'll call that P, C, D. Then the measure of that angle P is going to have the same general rule. Look for the bigger arc that's getting trapped between these 2 secants. The bigger arc on this problem would be BD over here, and the smaller arc would be little baby AC that's tucked in here. And so I can say that the measure of this angle P is again the measure of the bigger arc, which is BD, minus the measure of the smaller arc, which is AC, all divided by 2. Or in other words, it is the big one minus the small one divided by 2. And then when we look at one last example here on the end, this is going to be what it looks like when I have 1 secant and 1 tangent. But they're meeting at that same one point outside the circle. So here's my point P again. And this time I've got a secant, so I've got one segment that's going to come like this, a secant. I'm going to call that secant PBC. And then I've got a tangent, which means I'm coming just to one point on the circle, and then that keeps going past the circle. It'll never hit it again. So there is my 1 secant and my 1 tangent picture. Again, the general rule is very much the same. It is the bigger arc that it's cutting into minus the smaller arc that it's cutting into, all divided by 2. So to write that out, the measure of angle P in this picture would be the measure of arc AC minus the measure of arc AB, all divided by 2. Or again, general rule, the big arc minus the smaller arc divided by 2. And just realize that on all of these, I just tried to keep the writing simple for you. Technically, I should have little m's in front of all of these arcs, meaning the measure of, the measure of, the measure of, the measure of. But I think it's easier for you guys for the first time looking at the rule to just write it down more simply. So that's why I write it like that. Okay. All right, so those are the rules, and that's it. The rest of the lesson today is really just practicing with those rules. So if you think you have the rules down, and you would like to try the sample problems and then turn the video back on to make sure you did them correctly, feel free. I'm going to go through all of the problems that you have to do here for extra practice. So, starting with problem number 1, we want the measure of angle B, which is out here. B is being formed by, and go ahead and color in. Look for what you have going on here. This is a tangent. Oops, my crayon just went flying. And this over here is a secant. So the rule that we just spent some time going over was that I would do big minus small divided by 2. Well, what's getting trapped in between here? When I look at what's getting trapped in between this angle that's formed, I have the big arc out here, and I have the small arc in here. So that must mean I need those two measures to figure out this problem. I don't know how big the bigger arc is right now, but I can figure it out because I have 60, I have 100, and I know the whole circle has to add up to 360. So if I take my full circle and I subtract that 160, then the rest of that arc out there, the one I need, must be 200 degrees. And so to find the measure of angle B, I would be taking arc AD, subtracting arc AC, and dividing by 2. That means I've got 200 minus 60, all divided by 2. That's 140 divided by 2, which is 70 degrees. So that's applying that new rule that we just learned. Okay, next problem. They tell me here that the measure of arc RV is 180 degrees, and they tell me that the ratio from US to UV to RS is 1 to 2 to 4. So remember, what we can do is take each one of these and throw an X on the end of them. So US I can represent with 1X, UV I can represent with 2X, and RS I can represent with 4X. Now what do I care if these are 1X, 2X, and 4X? Because I also know this one is 80, which means I know this whole circle, of course, adds up to 360 degrees. So the first part of your work here is to figure that if all the arcs, 1X, 2X, and 4X, and the 80 have to add up to 360 degrees, can you go ahead and solve and figure out what the value of X is? And of course you can. So when I add these together here, I'm going to have 7X plus 80 is equal to 360. I am going to subtract the 80 from both sides. So 7X is equal to 280 degrees. And when I divide by 7, X is equal to 40 degrees. That allows me now to go back through and find all these missing arcs. US, of course, is 40. UV is 2 times that, which is 80. And RS is 4 times that, which is 160. Now, did I have to do all that work? No. I only need this little arc in here. But if you take the time to find all of them the way that I did, you can also do a quick mental check and make sure that the circle adds up to 360. Make sure you didn't make any mistakes. Then, to finish the problem, again, we are dealing with what's getting trapped inside. When we look inside of this angle, I have a big arc and I have a small arc, and now they both have labels. The big arc, the one further away from angle T, is 80 degrees, and the small arc, the one that's closer in there, is 40 degrees, which means in order to find the measure of angle T, I would do the big arc, 80, minus the small arc, 40, and divide by 2. So 40 divided by 2 is, of course, 20 degrees. And then you have one more practice problem on this page. On this one, they tell us that major arc MO is 200 degrees. Major arc means the bigger arc that connects M to O. So obviously the bigger one would be to go around this way. So that larger arc that's connecting M to O is 200 degrees. That would allow you to take the full circle, subtract the 200, and figure out that the other arc must be 160 degrees. And that makes it really easy for us to find the measure of angle MNO, because MNO is this angle up here at the top. And of course, if I look at what's getting trapped inside of that, I have these two arcs. They're the only two arcs in the picture. So the bigger of those two arcs is this 200 degree arc that's going around the outside. The smaller one is the 160 degree arc that's getting trapped in here. And so in order to do your work for that problem, you can figure that the measure of angle MNO is going to be the bigger arc minus the smaller arc, all divided by 2, for a grand total again of 20 degrees. Questions, problems? I hope not. Okay, and then moving on to the next and last page, you have the idea of what we're going to spend some time on tomorrow, which is called a super circle problem. Now, what that means is that it takes a whole bunch of the rules that we've learned over the course of this unit and it puts them all together. So the good news is that I'm not teaching you anything new tomorrow. All we're going to do is practice with problems like this, where they give you one big picture, they give you a whole bunch of information, and then they ask you 4 or 5 different questions looking for different parts of that picture. My advice to you every time you do a problem like this is to make sure that, if possible, you label the arcs around the outside first. That is the easiest way to get these problems going, and then you can continue from there. The other really important thing is that you actually read all of the words that come with it, because sometimes little necessary facts are buried in these words, and if you don't read them, you're going to get stuck and not be able to do the rest of the problem. So they tell us here that in the accompanying figure, triangle ABC is inscribed in circle O. So they're mentioning we have a triangle there, which means if you want, you're allowed to use the fact that the angles in a triangle add up to 180. If it's useful, you'll have to see what happens. They also tell me, and this is what a lot of people often miss on this problem, they tell me that BT bisects angle CBA. I'm using my crayon like a highlighter here. That's really important. If you don't read that, you're going to end up being totally stuck. So angle CBA is over here. If BT is bisecting it, that means we know before we start that if we can get one of those angles, we also can label the other one. That's super important. They also tell you that TA is tangent to circle O, so they're just confirming that you know it's only hitting the circle at that one point. And then it gives us a ratio of a bunch of angles. It says the ratio of angle BAC to CBA to ACB is 2 to 3 to 4. Well, if you go see where those are, and you throw an X on the end of each of these, angle BAC is over here. That's the first one, so that gets a 2X. Angle CBA is this entire angle in here. This entire thing is the middle one, so that is 3X. And angle ACB, which is this angle over here in this corner, this one is the last part of that ratio, so that would get labeled with a 4X. Now, why did they tell you that? Well, they told you that because you're supposed to see here now, that's why they were talking about triangle ABC. Triangle ABC is sitting inside of this circle, and we know from earlier lessons this year that all the angles in a triangle add up to 180 degrees. So that allows us to figure that those 3 angles, 2X plus 3X plus 4X, those angles have to add up to 180 degrees. And that's how we start to get some numbers in here to get the rest of this problem going. So when I add these up here, I get 9x is equal to 180 degrees. Divide by 9, and x is 20 degrees. If x is 20 degrees, that allows us to go back now and find all of those angles. 2 times 20 makes this angle 40 degrees. 4 times 20 makes this angle 80 degrees. And 3 times 20 makes this entire angle 60 degrees. Now, how is that useful to us? Well, in a couple of different ways. First, they wanted to measure angle BAC. We just did that. So all of this work even could be applied to that part of the problem. And then, of course, angle BAC was 2x, which would be 2 times 20, which is 40 degrees. The next thing they asked me for is the measure of arc BC. What we are supposed to realize is that BC is across from this inscribed angle that's 40 degrees. So if this inscribed angle is 40 degrees, the arc that's across from it has to be double that. So this will be 2 times angle BAC, which means it is 2 times 40 degrees, which means that arc around the outside there is an 80-degree arc. And I'll label it on my picture because that will be useful in later parts of the same problem. Sorry, I didn't have that up there. Now you can see it. Next up, they want me to find the measure of angle CPT. Well, in order to do that, I'm going to need more arcs labeled. So let's talk about labeling some more of these arcs. If this angle up here is 60 degrees, then we know each half of the angle is 30 degrees. And then those are both inscribed angles. So this arc over here is 60 degrees, and this arc down here is 60 degrees. And then we also had this angle in here that was that 80-degree angle that we figured out. And if that angle is 80 degrees, that is inscribed to this arc that goes around the outside of the circle. So 2 times 180 is 2 times 80 is 160. Once you get all the outside arcs labeled, feel free to add them back up, put it in your calculator, and make sure you add to 360. It's a good way to check yourself. Now the next part of this problem wanted me to find angle CPT. When I look for where angle CPT is, that's one of those weird angles that's inside the circle, but it's not at the center. So remember, in order to figure out that one, I have to add its arc, and I have to add its vertical angles arc and divide it by 2. And that means in this problem, this is how I would show my work. I'm going to add together that 60-degree arc and that 160-degree arc, and then divide by 2. And when I do that and add those together, I'm going to end up with 220 divided by 2, which is 110 degrees. Now, I've heard some interesting things from people, which are fine with me. Some people actually don't like doing what I just did. Some people would rather find the angles inside of a triangle and then use vertical angles, or the angles inside of this triangle and then use supplementary angles. If you see that stuff, you can use it, but sometimes it's a little hard to see. All right, next problem is they want me to find the measure of angle PAT. When I look for where PAT is, from P to A to T, I'm talking about this angle here. What you're supposed to realize, of course, is that this part is a tangent, and PA is part of a chord that actually comes all the way down to C. And so this angle that they're asking me for is half of the arc that's getting trapped inside of it. The arc that is getting trapped inside of that angle, look at where the angle goes. It's all of this. The arc that's getting caught inside of that angle is both of these 60s put together. So in fact, the work here is that it would be all of arc AC divided by 2. That means it's 120 divided by 2, which is 60 degrees. Doing it half in pen and half in crayon. And last but certainly not least, we're looking for the measure of angle T. When I go back up to this very, very, very busy picture now and try to find angle T, realize that angle T is sitting all the way out here. This is the rule that we just learned about today. In fact, this is the only rule right now that we learned about today. To get the measure of this angle, I can look for where it's hitting the circle. It's coming this way with a tangent, and it's going this way with a secant. And so to find the measure of that angle, I can do the big arc minus the small arc divided by 2. In this case, that would be 160 minus 60 and divided by 2. That gets me 100 divided by 2, which turns this into a 50-degree angle. And that is your final problem for today's lesson. I know this last one is definitely a little tricky. They always are. I would highly encourage the use of some crayons and some different colored pens. You see what mine has turned into here. Look at all those different colors that I used. So of course, feel free to use some colored pens, crayons, markers, whatever, to make that a little easier. And that's it. I hope you have a good rest of the day, and I'll be back soon. Bye.